Last time we did long division. Today we're going to do something called synthetic division. I guarantee you'll like it better. It's a little cleaner, a little more organized, but you can't always do it. You can always do long division, which is nice. So in order to use synthetic division, the method we're going to use today, you have to be dividing by linear binomials. So linear just means x to the first power. Binomial means two terms. So it might be something like if you're dividing by x plus 11 or x minus 4 or even if it was like x minus 1/3. It just has to be two terms and it has to be x to the first power. So you couldn't do it if it was like dividing by 2x minus 9. It needs to just be x and then plus or minus something. Now, you can make something like that work, which we'll see actually with example 1. Here would be, also you can't do it for like x squared minus 8 because x to the second power isn't linear. It needs to be x to the first power plus or minus some number. So, all right, here we go. Circle all situations to where synthetic division could be used. Has to be x to the first power, and it needs to just be plus or minus something. So sure, this first one could work because you could divide by x plus 3. Second one doesn't because that x to the third. Third one, nope, not as it is. We will be able to fix that, but you couldn't have the 8 in front there. X squared, no, x squared. Here, x minus 1/3, sure. And here, x minus 8, all right, fine. Let's get into it. Here we go. Now, dividing by 2x plus 1. Already, I know you're like, it needs to just be 1x. How could I go from 2x to 1x? You would divide everything by 2. So we are going to divide every single thing in this problem by 2. And then we'll be good to go. So let's see here. So 6 divided by 2 is 3. X to the second. Now we can't, you could make 7 over 2 3.5, but it's not necessary. You could just leave it plus 7 over 2x, and then 2 divided by 2 is 1. And we're dividing this by 2x divided by 2 is x, and then plus, and we're going to leave it 1/2. Great, so we're ready to go. So here's how you work it with synthetic division. In the box, you're going to write the 0. It just is the opposite of what it looks like. So if I'm dividing by x plus 1/2, in the box, I'm going to put negative 1/2. Right? So if it's plus, put a negative up there. If it was minus, you'd put a positive up there. Across the top here, I'm just going to write the coefficients. So it's 3x to the second power. So we just write the 3. It is 7/2 x, or 3.5. We don't need to write the x, just the number. And then it's the plus 1. We're set up and ready to go. Here's what we're going to do every time. You bring the first digit straight down. Great. Here we go. Now the tough spot. So you're going to take the number in the box. You're going to multiply it by whatever's down here. If you're multiplying a whole number by a fraction, just remember to multiply it in the numerator. So negative 1/2 times 3, 3 would go up top. Negative 1 times 3 is negative 3 over 2. Now if we add these straight down, 7 over 2 minus 3 over 2 would be 4 over 2, which we'll just write what that really is. 4 divided by 2 is 2. So that came out to 2. Great, and you keep going with that pattern. You multiply the number in the box by what you see down here. Negative 1/2 times 2 is negative 1, and then you just add in that column. 1 plus negative 1 is 0. Great, we're ready for our final answer. So here's what you do for your final answer. This problem started off x to the second power. You're going to bump everything down a degree. So this would be 3x to the first power, and then plus 2. That's it. This 0 back here is like our remainder. So if you had something there, like if that was a 7, you'd say plus 7 over whatever you were dividing by originally, 2x plus 1. But we didn't have a remainder on this one, so that would be our final answer. So you bump everything down a degree for that final answer. You'll get in the flow of this and you'll like it so much better. So here we go. We're dividing by x minus 3. So in the box, I'm going to put a positive 3, right? Because it's x minus 3. I'm going to just write the coefficients. Now we have 1x to the fourth, negative 2x to the third. Then it jumps to x to the first. And just like with long division, you got to put place fillers in. We have 0 x's to the second. So as silly as it feels, you have to put the 0 there. So here was our 1x to the fourth, negative 2x to the third, 0x to the second, 3x to the first, and then 1. We'll bring down the first digit, always. 3 times 1 is 3. And then we add negative 2 plus 3 is 1. 3 times 1 is 3. Plus 0 is 3. 3 times 3 is 9. Plus the 3 is 12. And 3 times 12 is 36. Plus 1 is 37. So we're ready for our final answer. So we started off x to the fourth. So for our final answer, this will be 1x to the third plus 1x to the second plus 3x to the first plus 12. And then that last number, that 37, is our remainder. So we could just say plus 37 over, and what we were dividing by. We were dividing by x minus 3. That would be our final answer. And a lot of people like it a little better than long division. It's just less subtraction maybe. It's takes up way less space. But again, you can only do it if you're dividing by a linear binomial, x to the first and some other number. Here we're dividing by x plus 7. So in the box, I'm going to put negative 7. I write the coefficients, 2x to the fourth, 14x to the third, negative 2x to the second, and negative 14x to the first. In case I need it, I'll put a 0 back here for like the constants. We might not even need that, but I'll just put it there just in case. We always bring down the first digit. Negative 7 times 2 is negative 14. Plus 14 is 0. Negative 7 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 7 times negative 2 is positive 14. Negative 14 plus 14 is 0. Negative 7 times 0 is 0. 0 plus 0 is 0. All right, so we bump everything down a degree. It started off at x to the fourth, so this would be 2x to the third plus 0x to the second minus 2x plus 0. Now, I know that's a little clunky, and we're going to kind of simplify what we can. We're not going to write the 0x squared or the plus 0 at the end, so our final answer would just be the 2x to the third minus 2x. That's getting a little better, right? The remainder thing, don't even worry about it. This part of the notes, don't worry about it. All right, example 6, we're dividing by x minus 2. So what are we going to put in the box? A positive 2. We write the coefficients, 3x to the third, negative 2x to the second, 1x to the first, and then a minus 4 back there. Always bring down our first digit. 2 times 3 is 6. Negative 2 plus 6 is 4. 2 times 4 is 8. 1 plus 8 is 9. 2 times 9 is 18. Negative 4 plus 18 is 14. Ready for our final answer? We started x to the third, so this would be 3x to the second plus 4x plus 9, and then that 14 is our remainder, so we say plus 14 over what we were dividing by, x minus 2. Okay, all right. We're dividing by x plus 2 here, so in the box I'll put negative 2. 1x to the fourth, negative 1x to the third, negative 10x to the second, 4x to the first, and 24. Bring down our first digit. Negative 2 times 1, negative 2. Negative 1 minus 2, negative 3. Negative 2 times negative 3 is positive 6. Negative 10 plus 6, negative 4. Negative 2 times negative 4 is 8, plus 4 is 12. And negative 2 times 12 is negative 24, plus 24 is 0. So there's no remainder on this one. Started off x to the fourth, so this would be 1x to the third minus 3x to the second minus 4x plus 12. Again, no remainder on this problem. We have 2 more of these problems to do together, and then you're on your own. Ooh, dividing by x plus 7. In the box, I'm going to put a negative 7. We have 1x to the fourth, 5x to the third, negative 14x to the second. I want to put a 0 for the x to the first, and then a 0 for my constant. Again, we might not need to go that far, but just in case. Negative 7 times 1, negative 7. 5 minus 7, or 5 plus negative 7 is negative 2. Negative 7 times negative 2 is positive 14. Negative 14 plus 14 is 0. Negative 7 times 0, 0. 0 plus 0, 0. Negative 7 times 0, 0, 0, 0, 0. Everything's zeros. Cool. So these we can ignore. Those are all remainders / unused items. So our question started with x to the fourth, so this would be 1x to the third minus 2x to the second. You could say plus 0x plus 0, but you would clean that up anyway. Last one. We're dividing by x plus 3, so in the box I'm putting negative 3. 1x to the third, 1x to the second. No regular x's. So put a place filler, and then you got your minus 10. Bring your first digit down. Ready to go. Negative 3 times 1 is negative 3. 1 plus negative 3 is negative 2. Negative 3 times negative 2 is positive 6. Plus 0 is 6. Negative 3 times 6 is negative 18. And negative 10 minus 18 is negative 28. We started with x to the third, so this would be 1x to the second minus 2x plus 6. And then the negative 28 is our remainder. So you could say plus negative 28 over x plus 3, or just say minus 28 over x plus 3. Either way is fine. That's it, man. That's some serious synthetic division. Serious.